In this video we'll see how to calculate the pi. So pi is using this it's 3.14 something, but we can calculate it by the series 4 minus 4 divided by 3, then plus 4 divided by 5, then minus 4 divided by 7, then plus 4 divided by 9. Then guess what? So it's can recognize the sequence minus plus minus plus. Now we have minus. Then as you can see, the denominator is after the first term here. It's always 4. We have 4 4 4 4, then we have 5 here. That's wrong. It's all 4. So we have 4 divided by 3, 4 divided by 5, 4 divided by 7. So the denominator is always 4. We can consider this as 4 divided by 1 to have the denominator as odd numbers 1, 3, 5, 7, 9. So this one would be 11. Now we have 4 divided by 11, and then plus and up to infinity. Or keep adding terms till we have the precision that we are looking for. Now to program such a for loop would help, or we can say while, starting with, say, int I equals 1. Now if we say I is less than this less than 7, then have float pi. Now pi every time is plus equals it should start initialized by 0, so the first time it would have a 0 value. Pi plus equals 4 divided by, to get the odd numbers, first time it's 1, then 3. This should start from 0. Okay, so it has to go up to 6. So I can easily have 2i, 2 times I plus 1. So this will start, if we start at 0, so the first term is 1, then when I becomes 1, this becomes, if this becomes 1, this is 3 plus 1, 2 plus 1 is 3, then 4 plus 1 is 5, and so on. If we are comfortable of having this 1, this should go up to 7, and this would be minus. So either way. So if we start from 1, this would be at the first iteration 2 times 1 is 2, minus 1 is 1, so we get this one. Second iteration it will be 3, since 4 minus 1 is 3, and so on. Never forget to increment I every time at the end. Then once we finish, see out I pi. Pi equals pi, and I'll compile it. missing semicolon, so we get pi equals 5. This means, because we have here an integer division, if we change it, now we have pi is 7.51. This is really far from 3.14. Yeah, now the reason we have wrong numbers is that every time we are adding, we should first term should be adding, second one should be subtracting, and we alternate adding and subtracting each and every time in the iteration. So to imitate that part here that wasn't included in the solution, we can always multiply by a factor. So we include a new, say, integer, call it sine, initialize it by -1, and then every time sine is multiplied by itself, so the new sine is every time it's multiply equals -1. This means every time I multiply sine by itself by -1, so since it started -1 times -1 is 1, then the next iteration it will be -1, then the iteration after that it will be 1, and alternatively one time it's positive, this next iteration will be negative. So all I have to do is here multiply sine by this factor, so I get this effect here, minus plus minus plus. Now if I calculate, let's repeat it here, 7, compile, so it's getting closer to 3.14. If I add extra terms here, like 20 terms, compile it, it's getting closer. If I just increase it to like 100 terms, I have a more accurate figure here. Okay, let's have it 200 terms. So it's becoming much closer to the accurate figure. So this is how we programmed calculating pi using this series, having this small code here.